Welcome to today's webinar. The topic today is 3D modeling for geotechnical analysis in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, newsletters, and so on. I will be the moderator today and will answer your questions together with Alexander. But yeah, my two colleagues can introduce themselves.
Hello, my name is Juliane Stopper. I'm working in the Dlubal team for customer support, and I'm also supporting the developers of the add-ons geotechnical analysis and concrete design. Yeah, and I will present this webinar today to you.
Hello, my name is Alexander Mayhofer. I'm the head of product engineering concrete. I coordinate the development for the concrete design and also for the geotechnical analysis. Today I will answer your questions in the chat.
Okay, thank you for your introduction. Then we can switch off our webcams so that the attendees can see the full screen. I say something about the questions for the participants who participate the first time. You can see on the right side of your screen a control panel. You can show or hide that with that arrow here, and you can show it and then enter a question here, and Alexander and me will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's all from my side. I hand over the screen to Juliane. Okay, maybe last hint, the webinar will be recorded, and at the end of the webinar, I will show where you can find the recording and the models and so on. Okay, now we can see your screen, Juliane, but okay. The first slide.
Yeah, that's it. Okay, then let's go to the next slide. Yeah, this is the agenda for today's webinar. We will focus on modeling for geotechnical analysis, and we will do this in these steps. In the first model, we will use a background layer for placing the boreholes, and we will use boreholes and generate a soil massif. In the second example, we will have a 2D terrain section, a geological section of the soil, and we will import this. It's a DXF file. We will import it and extrude it to have our solid. In the third example, we will use the IFC interface. We will import a model, and we will also use the Boolean operation with intersection. We will modify our soil massif to have a lower, let's say, basement floor integrated into the soil. Yes, after that we have finished the modeling part. In the fourth part of this webinar, we will have a look at a simple small model and prepared for the analysis and do the analysis with it. Yeah, that's it for the agenda. We can now start. We will therefore open the program, and yeah, here we see RFEM, and I open a new model with this button. Then we come to the base data dialog, and we will enter a name. It's my model number 1. In this register, I don't need to change anything. We can jump to the add-ons register and activate our geotechnical analysis add-on. This we can find here in the area where the special solution add-ons are placed. So I activate it and press OK. Then our model is prepared. The add-on will be integrated into RFEM. So here we go. We have an empty model now, and we can start modeling. Therefore, at first we go to the materials, and I will create our materials that we need in this first model. I therefore will use materials from the library. We can open the library via this button, and I will use a gravel, a sandy gravel as first material. I can apply this. Then I will add a next material. We can have a sand, maybe coarse sand, and we add a third material. We will use a medium plastic clay. This is just an example of materials because we will focus on modeling today. So yeah, I agree. Maybe, yeah, no, one more thing. When we have the geotechnical analysis add-on activated, we can select the material type soil. And when we have a material of type soil, we can here in the material model part find the special, the valid soil material models. We currently therefore have the Moore-Coulomb model, and we have a nonlinear elastic material model. This model is able to represent the stiffness dependency, the stress dependency of the stiffness of the soil, and it also uses different stiffness for first loading or unloading and reloading. And we will have the hardening soil model in the nearer future. It's in the last steps. It's in around about 6 weeks. We will probably release this. We will then inform you on our website. Okay, but I leave it like this for now because it's more, the focus is on modeling. And the soil materials, they are always user-defined materials, as you generally have to edit the values and enter the values that are valid for your project. Okay, so we have 3 materials prepared. We can see them here, and we can go on. We will go directly to the special objects, and here we can see 2 special objects that came with the add-on geotechnical analysis. We have here the boreholes, and we will now use them. Here we see the dialog for entering boreholes. The boreholes, they provide you an option to directly enter the data you have from your geotechnical report. You have for different locations at your field where you will construct your building, you have for different locations values along the depth that came from that report from tests and so on. And this you can enter here. You can enter the location of that borehole. You can enter a groundwater level. We will do this here. We give 4 meters. And here you have to, or you can assign the soil layers. We start from the top and go into the depth. We have, in my example, we have the sand at the top, and it's 2.5 meters deep maybe. As the second material, we discovered clay or found clay. It shall be 2 meters, and then we have the gravel, which is 15 meters in my example. Okay, yeah. Now we have the borehole data given, and we can say okay. Then we see here our first borehole. I will remove this work plane. I will deactivate it so I don't see it anymore. Here we have the first borehole, and we need some more. We have, of course, more in our field, and I therefore now will use the background layer. We can find it here in the navigator in the guide objects. Here at the bottom you can find the background layers, and I will open the dialog. As a background layer, we will import an DXF file, and I can do this here. I can directly go here. And here I have the plan of my area, and in that plan the locations of the boreholes is given. I see that I have to transform this. You can do this in this dialog, and this is the plan how it is correct. And I want to use an option. I want to use the option use layer identification. I activate it. And there you can select the layers of your DXF file that shall be used for the background layers. I deactivate the DL nodes. And this is a preview, and I accept this, and this is fine. Okay, now this is, let's say, my map with the positions for my boreholes. I will modify the object snaps. You can also find in guide objects. I only now want centers to be picked, and I say OK and set to active. So now I want to place more boreholes via drag and drop at all these locations. Therefore, I create a node at the top just to help me doing this. Okay, now I can select this. Now I select like this. I have my borehole and this helping node selected. I press Control and I can move it to the place in my background layer in the graphic. And as you see, the last copy is always selected, so you directly can go on with copying with drag and drop. Okay, that's it. Now I have in all the locations my borehole. Okay, I wanted to delete the initial one because there's none. Okay, now I have at all the locations that I got from my project partner with that plan, I have placed these boreholes. I will delete these nodes. I just needed them for the process. And now I have my boreholes prepared. Yeah, and there was no need to measure these dimensions or to fill in data manually. You could just use the drawing. Okay, then I want to use my boreholes. I can use them for creating the soil solid that shall be analyzed. And therefore we have our second special object. You can see here we have the soil massifs, and I open the dialog for this. With the soil massif, you can generate from boreholes the soil solids that you need for the analysis. Therefore, you can here enter manually the numbers of the boreholes, or you again can select them graphically. There I have them assigned. Then you need to give geometrical information for the soil massif. You have to enter a center. I keep it with 0, and you have to give the dimensions. I will give it 40 meters along both sides. And we have the option to activate a groundwater level. Okay, we gave all the input that is needed. And now here we can see our soil massif, our soil solids were generated. I switch on the solid model. We can see it more easy. And we have here in the navigator for display the option to change the display so that the color is dependent of the object property. We can also see here the material and the color that belongs to each material. Okay, so what came with our soil massif? Our soil massif generated 3 soil solids for us. We can find them here. For each soil layer, 1 solid was generated. And we also have a groundwater level surface generated. And we have, we can find here, surface supports generated. This and this. We can see them also in this window when we go to wireframe model, for example. Here we can see it. We have at the vertical boundary surfaces, we have sliding support, so only in the local Z direction these surfaces are supported, and we have fixed support at the bottom surface. Okay, so with this generation, the solid is connected to these boreholes. So if you change data in the borehole, if you change a layer thickness or something, the macizo will be automatically updated. Yeah, so that's it. This is what I wanted to show with the first model. We can go to the next example. This one is prepared. Okay, I will save it and we go to another RFEM for going on with the next topic. In this next topic, we want to use an DXF file again, but we will not use it as background layer. We will directly import it. And this I can do here. I go on File and go to the Import button. And here I can import a DXF file. I have to select the file. I have it here. This is a geological section of the ground, let's say, a drawing. And we will come to an import dialog where we can do last settings before the import. Yeah, here it is. Here again, I can use this layer identification. And again, I don't need all these nodes. In this case, my model is prepared. I don't need coordinate transformation. So I can say, okay, it can be imported. So, and this is it. I have here now the DXF file imported, and now we can see the difference regarding the background layer. Here we have real objects imported. We have lines and we have nodes, and we can work with them. We can edit them, modify them, use them. Yeah, and this is what we will do. We will use them. My plan is, what I want to do is to extrude this model into the depth, and therefore I need a surface here. And this we are going to do. We have here this button. Here we can create surfaces, and I use the select boundary option. I need a stiffness type without thickness. I don't need a thickness. It's just a surface for being the boundary surface of a solid. Okay, I have the first one. I select the next lines of the second surfaces, and the third surface is generated, not generated, defined. Okay, then I want an opening here. This is, yeah, let's say the shape of a tunnel here, a small tunnel. And we have here the option to create openings. And again, I use this graphically option where I can select the boundary lines graphically, and my opening is being created. Okay, with escape, I can leave this tool, and yeah, my surfaces are ready. Only I want to check the local axis. I can do a right click and switch local axis system off on the display. Now I see my surfaces local axis, and I see this one is showing into the other direction. I want to have them the same orientation. So for the surface, I reverse the local axis system. This helps me now for my extrusion. I now select all these surfaces, do right click on them and go on surfaces. And here I have the tool, the option to extrude, and I extrude surface into solid. Okay, I have here this preview, and but I can go here and enter the value I need. I want to have -1 meter. The extrusion. I can apply this, and my model is created. I will switch off the local axis systems. This is a model that can be used if you have plane strain conditions. Then it's enough if you just cut such a thin layer of your model, and then you can model it. It is usable for plane strain conditions. Okay, so now here we have solids. What we need is the material. I have materials prepared for this model. Therefore, I want to use the Excel import. Let's say I will do it like this. I have here my material and I import it. Okay, and now I have materials. Yeah, I will also go to the base data. As we started with the import, we didn't activate our add-on yet. I will do this. We go to add-ons register, and again here in special solutions add-ons, we have it now activated. Okay, now I modify my solids. They are all standard and they don't have the right material. So I double click on the center of gravity and I can change the solid type. I choose soil and my first layer, yeah, can have the gravel. Okay, this one is ready. I go to the next one. Here I have a sand. I will use this one. And of course it needs to be soil as well. This is needed, yeah, for having the right material models, the option to use them. Okay, I go to this one and I also set it on soil, and I will go to this material. Okay. Yeah, then I go here. I will change the display so that it is dependent on the object property. If we look here now, I can see that I have my 3 materials used. Now the geometry is fine, it's finished. What I want to go on with is the boundary conditions. I go to the transparent view and I select my boundary surfaces. With Control pressed on, can select all of them. Okay, and now we can do a right click here and edit my surfaces and go to the options and activate the support for these surfaces. I have here some surface supports that I can use. I will use this one, but we can have a look inside also. Here we can see that the Z direction of the local axis is supported, and we can see it in the display now also. Okay, now I with escape leave these selected surfaces and I select this one, the bottom surface, and this gets a support as well, but the fixed support. Okay, now my model is supported. I switch on off the display of these supports in the display navigator. It's more easy to have the overview. Okay, now I want to go next step. I want to create the mesh. I'm doing this here. Yeah, and I have a mesh which is relatively coarse for this example. We can find the mesh settings here and calculate and mesh settings. And we have here a general setting for the target length of the finite elements. This is valid for all structure parts. And we have an additional setting that you can find here in solids. This is valid only for solids of type soil. So we have an own setting for the target length. Now here for this example, I want to have a finer mesh. I say, okay, I don't apply it yet because I want to use another feature for the mesh. I will show you now. I select the solids and go to the center and say solids, edit, because I go to the options. I want to use a mesh setting, the layered mesh. And I activate it for all the 3 solids. The layered mesh creates the mesh on the surface, and on the other side of the solid, the surface will get the same mesh, and in between there are layers created, and you can here define how many element layers shall be used. For this model with plane strain conditions, one element layer is enough. So I set this on 1 and say OK. Currently, it is needed to go here to the layered mesh. This will be worked over, so you don't need to later to go there. Okay, now we have the layered mesh activated, and I will create my mesh. Okay, and I can see a nice mesh. We will go to the navigator for display. Currently, we see the mesh of the surfaces, of the boundary surfaces. If we want to see the solid mesh, we have to check this button. And here we can see the mesh in the solid. It's quite regular. And we can see we have only one layer element. One element along the depth. Okay. One last thing I want to show, you also can here activate the mesh quality, and you here have an additional register where you can see the color, and here you get information about the quality of your elements, and you can also see if there's a warning or even a failed element. The criteria for these categories you can find here in results, now in calculate and mesh settings, and here we have the register or the criteria. Okay, yeah, that's what I wanted to show with the second model. This is finished. Now we can come to the third model and the last part of the modeling part of the webinar. I have here, for the third model, I want to use with our first model, I want to go on with it. For showing the IFC import. Here we have our soil solid prepared. What I don't want to see now anymore is this background layer. Therefore, I can go to guide objects. We have here the background layer, and I can deactivate it. So it's there if you need it for graphics or something. You can switch it on again, but now it's not shown. And here I want to import now a small IFC file of a model. Therefore, we go to import, and we have here IFC, and I'm choosing this IFC file. We will use this. It's a very small thing, but enough for explaining the procedure. This model needs a coordinate system transformation. Therefore, I mirror Y and Z direction, and I say OK. Here we have some information about the import. I can see which parts of the IFC model were imported. So you have an option to control whether this is what you expected. Okay, now here we have a kind of IFC viewer, of our own IFC viewer. You have here in the navigator an overview about the parts of your IFC model. The IFC structure is a graphical object. It is not. It doesn't consist of objects that you can use for the analysis. So you have to convert them. You have to because we need a model for the analysis. We have to convert these graphical objects. We want to do this now. One option you have is you can use this graphical information with object snap, and you can model manually your parts of the structure you want to create. The second option is you can convert graphical objects you have here and use them. I now want to, for example, switch off the slab. Now we can have a look inside of the model, and I want to convert this beam. So I can do a right click here on this beam and say convert into straight member. This beam hasn't got a material yet. That's why it's displayed in red, because we had only soil materials before in this model. So I can see it in the Edit Member section dialog that there's no material. I can create from here a new one. The dialog opens that we also reached via the main navigator. And here I can add a concrete. I will use this one. Say OK. Then our beam has a material as well. OK, you can do it like I did. You can click here and say convert. But you also can do it from here, from the navigator. For example, you can also convert all walls in one time with one click. But I don't want to go into it too deep. I just want to show this example. You have to do some kind of overwork. It's not enough to convert it. I will show here. I will now also convert these columns, convert into straight member. And it can only convert what is existence from the drawing. And the drawing had these shapes. And what we now can see, if we look to our RFEM structure, these were now converted. If I switch off the IFC model, I can see these are existent in my RFEM model because I converted it to analysis objects, but I can see that they are not connected. So I have to do some overwork after I converted all this. For example, in this case, we can extend them up to the next member, and then they are connected. Yeah, so some work needs to be done to have the full analysis model. We have own webinars for this, for different interfaces for the import of IFC files or SAF files. You can find several webinars that go into the deeper explanations for this. I will here now stop this. I just wanted to show this option. This option. We will go to a next model where this conversion is done. I will go here. I have it here prepared. In this model, I had a building that was imported via the SAF interface, and it is prepared now for the analysis in RFEM. So however you reach this model, you can use IFC import, you can use SAF import or other ways, or directly model it. If you have finished your building, you can use this building to modify the solid so that they are connected. If you have a building that has a foundation slab that ends on the top surface of the soil massif, it will be automatically integrated. But here in this case, we have a building with a basement floor or cellar floor that is in deeper zones of the soil massif, and it is not yet integrated. Up to now, the building and the massif, they don't know each other. They don't share nodes of the elements, and they wouldn't share stiffness, so building is not supported yet. That's what we have to do. We have to model it so that it is integrated, and I want to do it with the intersections. I want to use a solid intersection to cut my surrounding solid, my soil massif, and this is what we are going to do. I will here in the basement floor create a solid kind of help object. Later I won't need it, but I will now use it for modeling the whole. Here we have extrude, and I say surface into solid again, and we need it to be minus 2.98 meters. I can say apply, And now I have my solid here. I can also see this. I have soil solids, and here's a fourth solid created. And this solid I will now edit and change the type of solid to intersection. With this solid type, I have the option to use Boolean operations, and I say yes. And then I can select them, can go on the model and say solids, and here we have the option to cut by solid intersection. And this is what we do. And then you can see that we have here now one solid at the bottom, and we have the upper layers, and they have now here the opening. And we also have in the building now the parts that were cut from the previous soil structure. Yeah, we can also have a look at this. Here we can see that an opening is created. We now will delete these soil solids that are placed in the basement floor. In further analysis, when you use construction stages, you can keep them and use them. You can calculate your initial state with all the soil solids, and in the next stage you can remove these solids. You can, with this, model the excavation and deactivate these solids. Here now, for just showing it, I remove them. Okay, so now I have only surrounding soil and I have my building inside. Yeah, we can again have a look at this. And yeah, now they are connected. They share these boundary surfaces, and the mesh should be good. I want to show you also our tools we have. We have model check tools. I want to use it because, yeah, this model was imported, it was overworked, and now we use the Boolean operation. So here some identical nodes were detected in my model, and I can use this selection to, yeah, kind of repair it, to unite nodes or delete unused nodes. I agree, and now these nodes are gone. Then I want to use the overlapping lines check, and I see I have some overlapping lines. For those, I will use this button. Okay, so if we look now, it is fine. Okay, then I want to do a last thing with this model. I want to create the mesh. It's a bit more slow because of the presentation. With GoToWebinar, generally it wouldn't be that slow. Okay. Yeah, and here we can see our mesh, and we can also now see that it makes sense with that we have different mesh settings for the soil solid and the superstructure. Yeah, that's it. Okay, I came to the end with the modeling part of this presentation. I will go back to the slides. Yeah, we finished the first 3 steps, and I will show kind of summary slide. Here we have the modeling procedures that we went through listed, and some additional. We have several interfaces in RFEM 6, and you can find there further information about it on our website. We have web service and API where you can create applications, for procedures you have to do again and again. Yeah, we have the integration of in Autodesk Revit. We have interfaces to Rhino Grasshopper. We have an SAF interface. We have an Autodesk interface. The DXF file that I imported, I could have also directly imported from AutoCAD. This is another option. We have Microsoft Excel export and import. We have DXF import export interface for IFC, and we have the background layers we saw. Then of course you can directly create the geometry and use all the tools we have in RFEM 6 for model creation. And then we have in our add-on geotechnical analysis special objects like the boreholes and soil massifs that support you with creating the model. Okay, that's it regarding the model part. Now we come to our fourth example. Now we will analyze a model. So I open the model 4 and we will have the model in plane strain condition. So I have taken this geometry again. I prepared it a bit. We have here this existing structure, this small tunnel, and I assigned concrete as material to it. And we have here, let's say, a kind of new structure that shall be erected. And what we want to analyze is now which stresses and strains happen in the soil and which kind of, which load, which inner forces will arrive here at the surface of the small tunnel. Okay, for this, yeah, I prepared the geometry. Let's go to the materials. One time. I have now the nonlinear elastic soil material used. Yeah, that's it. You can find more information in the online manual regarding the soil material, all the soil materials. And in the last webinar, I spoke about this material model. Okay, then I have mesh refinement used. We can see here. You can find the refinements in the types. I used a line mesh refinement. And when we have a look inside, here's the assigned lines. Yeah, we can remove it. I only wanted actually to assign these lines because it's something nice. The layered mesh automatically extrudes it into the depth, so it's not needed to in the next step to again assign the lines. It's with this one line it's done. Yeah, you can see. Okay, so we have this. Then all of the topology is prepared. We can go to the loads and open the load cases and combinations. I click here on new load case. I deleted here all previous settings, so we start from scratch. We will define a first load case. We will have the self weight of soil. Therefore, we have an own action category that comes with the add-on geotechnical analysis. It's the permanent soil action category. With this action category, it's possible to activate self-weight only for soil solids. We need this because in the geotechnical analysis, you need this self-weight of soil load case always as initial state, at least. Okay, then we create a next load case. I have no static analysis settings given yet. I have to do this. So I create a new setting, I will take the default option. Only I will here use 4 load increments because we have the nonlinear material model used. Okay, I apply this and create a new load case. Now I want the self-weight of the superstructure, so I select permanent action category. And here now I have again the option to activate the self-weight, and now the self-weight of all structure parts will be used except of the soil solids. So it's self-weight of structure, let's say. So, okay, then we have 2 more load cases in this example. We have a load case dead load of the, let's say, new building. And we will have another load case, which will be live load. Oh, what did I do? And this needs the action category for imposed loads. Yeah, I will use this one. Okay, I go on apply and we will go to the next register. Here you have an overview about action categories that are now existent in your model. We can go on. We have here design situations. I will create a new design situation. I want to use one in this model, a characteristic design situation. And I want my, I can show this maybe, here in the base data you can activate the combination wizard. Then your load combinations can be generated. You also have to give the standard that shall be used for the generation of the load combinations. So I can here now give some settings for this combination wizard, some information about what shall be generated, and I want load combinations to be generated, and I don't need any other setting here. Okay, then we can see the actions combined and the resulting load combinations. Okay, I need another combination. I use the generator, but I can add also manually defined combinations. I want to create, and I need to create my initial state. In my initial state, the self-weight of soil shall be active, and I also want to have the self-weight of my existing building to be active. So I want to calculate the state of my environment or my soil and this structure before this building is erected. So I have self-weight of soil and self-weight of this structure. I need to do something so that this structure is not considered in the self-weight, because this load case would consider all structure self-weight. Therefore, I have here in the options the structure modification that I can use. I activated it, and we can go into this. And we have here the structure modification. I will give it another name. It's deactivation of the new building. Okay. And you have here the option that I used. It's deactivate objects. And here in this window, you can select the objects that shall be deactivated. We have solids that shall be deactivated. And in here, only one solid is selected. We can control this. If I look here, I can see, yes, my new building is selected. This is fine. I can agree all this. And I have my structure modification active. So in this load case and in this load combination 3, my new building will be not yet considered, which is fine because I want to have here the initial state calculated. I also create a copy of this load case. I now want to have following situation for my initial state. In my initial state, I need to know the stresses of this soil, because the soil material reacts stress dependent. So I need to know which stresses are there for using the right stiffness for further loading. What I don't want to know is the displacement. I want it to be reset to 0. When my building is started, I want the displacements to start to be considered. Therefore, we have a special static analysis setting. We can again go here, and I will create a copy of this and rename it. It's actually the same as SA1, only it is for undeformed structure. And the setting you can find here in options 2. We have here the option equilibrium for undeformed structure. So when you use this setting, the equations that will be solved, the model will be solved, the stresses will be calculated, but the deformation will be reset to 0. Okay, this is what we want, and for this combination 4, I will use it. Yeah, and I want this initial state with 0 deformations, but with the stress state to be considered in my combinations 1 and 2. So I select these 2 combinations, and here in special options, you can consider the initial state, and I select this one. Okay, so my loading in these combinations starts with the stresses and strains of, the deformations are set to 0. So with the stresses of this model, yeah, and the deformations are kept as 0. Okay. So now we have this prepared. Yeah, what we need is loads. We created load cases, but we have to give also loads. I will use this button here and define a dead load for the new building, and I say OK. The dialog opens. I can select the surface. This surface will be used, and I will assign 100 kilonewton per meter square. Now what I wanted to show is that you actually can stay in this dialog and press apply and next, then it would be open, but okay, I closed it. So we now can use live load. I will again assign the surface, and you can use 125 kilonewton per meter square. Okay, we can control this graphically. We have the live load and the dead load, and if we look in the combination, we have both of them. Okay, that's it. I can also give some more color. I have something prepared for this model. I prepared a printout report for us. This can be found in the navigator at the bottom. Here you can do a right click and create a new printout report. You come to printout report manager. Here you can select the topics you want to have in your report. I cancel this as I have already prepared it. I would like to shortly show. I prepared it so that I can print graphics now during the analysis process. Yeah, we will do this. Where is it? Okay, this is the first version of my report, and we have something good. You can change the language. We can here in edit set the language. We want English language. So this is a nice feature. You can work in your mother language, and when you work for other countries and you have to give another language, you can change this. Okay, I will close it, and we will now from time to time print into it. So I want to also print this loading situation. So we can go here on File, Print Graphics to Printout Report, and you get a preview. And I want to only print the current window. And here we see a preview, and it looks fine to me. I say OK. Then it is saved in the report, but it will not be shown, and I can go on working. I can have a look later. Okay, now everything is prepared and we can start the analysis. We can go here to calculate and say to calculate. And now I would like to at first show this one. This is the initial state where the displacement is reset to 0, and you can also follow this. Here you can see the load increments, how they are assigned, and we can see that the displacement is always reset to 0. So this typical diagram for this setting. Now this initial state is calculated. I want to also calculate the rest. We also could have before selected this. I will select the design situation, characteristic, and then all the contained combinations will be solved. So I select this and say OK. Yeah, here we also can see the load increments. And it's okay. Now it is done and we can have a look at the results. First of all, I want to remove the results of this helping structure. Let's say we don't need to see this. I can here in the control panel select what shall be displayed, and I want to have the object selection. I prepared a object selection that only contains soil solids. Okay, but first of all, I want to go to the initial state. So what we have here is the initial state. It's the self-weight of soil and self-weight of this structure. This we deactivated. We have a deformation here. And we have of course, stresses. And this is what I said. I also deactivate the mesh. This deformation we don't want to see in our results. That's why we reset it to 0, because when I go and start my construction of this building, for me, there's 0 displacement at the beginning of this load case, let's say, or load combination. So that's why we have this copy where we said reset displacement shall be used, and we can see it worked well. The displacements are 0. But if we have a look at the stresses, we will see that we have stresses. And we can also compare it with the previous combination, and we see it's the same. So this is the initial state stress, the geostatical stress, and you can also control it. You can check it with hand calculation. You can calculate with the specific weight and the heights of these layers. You can compare it, and you will see it's plausible. I did it, and it's good. Okay, then we have, we can print the graphic. So we have a graphic of the initial state in the report, and I like it, so I say okay. And then we can go to the next load combination, and I will go to the leading one with the highest loads. This is this one. So at first we can look at the deformations, and here we can see how, with this helping structure, let's say, it deforms, and how the deformations, goes to the deeper soil layers, and we have here the deformations. Okay, but now we want to have a look at the stresses. We can here select solid stresses, and what we have here is the final state of this combination. So we have stresses of the self-weight, of the soil, of this structure, and also of the new building. We have the option to select another type of result. You have the option to just see the stress that came through the delta load between the initial state and this combination. So what came after the initial state is only this load, and if you activate this button here, you will see the load that came plus to the initial state. And we can see now the stresses that are caused only by the new building. And here we can see very well how it goes into the soil, into the deeper zones, and that here some stresses reach our shell of the tunnel. Yeah. I want to also print this one to the report. And we have again our preview, and it's fine. So we again cannot say OK. And I want to also see the final results and print it to the report. Okay. A last step, I want to show that we can also have a look now at our tunnel, at our construction. We want to know what comes there. And I have created a result beam. If we see here, I put a line in the center of this surfaces of the tunnel shell, and there in the middle I placed a result beam that integrates stresses and forces of these surfaces that I assigned. So the surface of the tunnel. That's why I can use now member results, and I can see what reaches due to this load combination in my tunnel. Again, I could also select the differences to initial state. So this is, for example, the moment that came only from the construction of this new building, and I also can look at the final results. So in total, I have this moment. Now I can also check other internal forces. I can check displacements and so on. Yeah. What we can do also is we can here select for members, as we have the result beam. We can also select a colored shape, and then we can print this as well to the printout report. And I want to use the multi-print because I want to have the same view, the same perspective. I will use this load case, this load combination, and here you can select what kind of forces you want to print. And I want to print the normal force, the My, and the displacements. Okay, I say okay. Yeah, this is it. I came to the end with that model. This is what I wanted to show you in this first or in this short analysis. This is the first step of the analysis of this situation. This is for first information about the stresses, strains, and displacements that are to be expected. In a further deeper analysis, the construction stages could be used, and it could be modeled. The phases of the situation could be modeled more in detail. Then you would model only the soil, then you could remove the soil in the next phase, construct the tunnel shell in the next phase, do the excavation here, and so on. This you could model with construction stages. Okay, but for today's webinar, this is what I wanted to show you. As a final step, I would like to have a look into our printout report. Yeah, and here we now have our report, and we have all the graphics that we printed besides. We have here, and we have an overview about the situation. We have our multi-print here. It's, and you can easily modify your report. You can, for example, click here and say start with a new page Then we have our tunnel information here. And one last hint, in the material, you can do a right click and say edit. And we have here the option to activate our soil material, that we get information about it. So it will be shown here also your the values you gave for cohesion, for E modulus, and so on. Yeah, maybe I should have pressed this button. Save and show. Then it should come. Yeah, this also is maybe a bit more slow because of the presentation with GoToWebinar. It's generally not that slow. Yeah, here, this is what I wanted to show. You have the option to activate this detailed information about the nonlinear elastic or the soil materials information. Okay, yeah, that's it from my side. This is what I wanted to show with this webinar. I hope yeah, I hope it gave a good introduction of modeling techniques, of import options, and that you can use if you have from project partners some files, some data. You can use it to make your modeling procedure more easy. Yeah, I thank you very much for your participation, and I wish you a nice evening and much joy with our software. That's it from my side. I would like to give the word back now to you, Andreas.
Okay, Juliane, thank you for this nice presentation, especially for the different possibilities for the modeling of the soil, and of course also for the design. Before I show the attendees where you can find the recording and models and so on, I would like to show a last PowerPoint slide. If you want to get a free product demonstration or a non-binding offer, yeah, just contact our sales team. You can click in the PowerPoint slide on that button, or you can scan the QR code. Yeah, just use the possibility. Okay, then I show our website under dlubal.com and news and events. You will find the webinars. That's the next webinars. Yeah, code formed steel design, USA, new features in steel joints, the next FAQ webinar. And that's today's webinar. I click on it. In the next days, you will get an email with a link to that page here. And then you will find the recording here. You can already find the presentation slides here in the middle. And you will find the models to download here. And then you can go through the webinar with the recording and provided models. Okay, that's also all from my side. Thank you for your attention. Thanks to Juliane for this nice presentation. Thanks to Alexander for the help by answering the questions. I wish all a nice rest of the day. I hope we meet each other in a future webinar. Bye-bye.